All right, this is going to be a short one for today. So we talked yesterday about logarithmic functions and their graphs and what they look like. And so we need to talk a little bit more specifically about the domain of a logarithmic function. Because as you saw, the log function has a vertical asymptote, which means our domain is restricted. So do we have to figure out where that asymptote is every single time? Do we have to graph it first? No, we just have to know the rules, okay? So there's two things. You cannot log a negative, and I would also add to this, you also cannot, whoops, that's a highlighter, or 0. You cannot take the log of 0, because if you think about what that would mean, if I had the log base b of 0 equals some number x, that would mean that b to the x power is equal to 0. Well, that's not possible, okay? There's no exponent that's going to turn a base of b, which is not 0, into 0. You can get really, really small, but it's never going to equal 0. So that's why this is not possible. So you can't log a negative. You can't log 0. You can't log a negative for the same reason. If I had the log base b of -2, that would mean that b to some power is equal to -2. There is no exponent that turns your base negative, okay? Remember, b is always going to be considered a positive number. And so there's no exponent that can turn your base negative. So that doesn't work either. So that means that this is the rule we need to follow, is that whatever is inside your logarithm, it must be greater than 0. So that's the algebra that we need to know. So, for example, if I have the log base 4 of x plus 3 and I want to know what the domain is, the rule is that x plus 3 must be greater than 0. So x must be greater than -3, which means our domain is going to be -3 to infinity. Okay? Go ahead and try b while I give you 3 seconds. So in this case, x minus 5 must be greater than 0, which means x must be greater than 5. So 5 to infinity is the domain here. Now c is a little bit trickier because we've got a polynomial function in there. The rule is exactly the same. X squared minus 1 must be greater than 0. But now we have a polynomial inequality. And remember, a polynomial inequality always needs to be compared to 0. So we don't want to add 1 to both sides. It doesn't work that way. We need to work on factoring the left side and figuring out where it's equal to 0. So that's going to be x plus 1, x minus 1 greater than 0. So our boundary points are going to be -1 and +1. Now, if you remember from last semester when we did our polynomial inequalities, now we need to consider those boundary points and we need to test some numbers. So if I tested a number like -2, a number like -2 is going to give me a negative times a negative, which is a positive. If I test a number like 0, I get a positive times a negative. If I test a number like +1 or +2, I also get a negative, or a positive, sorry. Again, because this is greater than 0, that tells us we want the positive numbers, and we can't include them because we just want greater, not equal to. So the domain in this case is going to be -infinity to -1, union 1 to infinity. So when I say all things at all times, I really mean it. Even though we're talking about logs and exponentials, you see that the work we did on polynomial inequalities is still relevant. We're going to see rational equations come up in this unit. So keep all your notes so that you have them to reference, but all of this is going to matter. All right. The last couple things that we want to talk about is what your calculator can do. There are two types of logarithms that we use on a regular basis. The first is the common log, okay? In science, they like to use the common log a lot because the common log is base 10, okay? So when you just see log written by itself, that is base 10. So I could say log of 5 that means log base 10 of 5. But this is kind of a shorthand accepted way to write it. We don't usually write a base of 10. The reason why base 10 is so nice is because that's going to be your powers of 10. 10, 100, 1,000. So that's going to be like millimeters, centimeters, meters. So that's why in science we like to use log base 10 quite a bit. And so when you use the log button on your calculator, it's only doing base 10. Okay, so number 8 says the percentage of adult height attained by a boy who is X years old can be modeled by the function f of X equals 29 plus 48.8 log of X plus 1, where X represents the boy's age from 5 to 15, and f of X represents the percentage of his adult height. Approximately what percentage of his adult height has a boy attained at age 8? So all we need to do is plug in 8 for X. And so if you go ahead and do that in your calculator, we want f of 8. I'm going to give you a second to plug that into your calculator so that you can see if you are typing it correctly. I'll be back in a couple seconds with the answer. So the answer that I get is 75.6. It didn't tell us how to round, so we're going to go with that. So that tells us that this boy at 8 years old has attained approximately 75.6% of his height where we expect him to be, okay? So that's our answer. So it's just when you see that log, that is a log base 10, and that is the log button on your calculator. Now, right below the log button, you'll see the ln button, and the ln button stands for natural log. This is when we are using the log base e. So if you see the natural log, that's an ln, not an I. Some people write it in, which is incorrect. That's an ln of, say, 5. That's the same as saying the log base e of 5. Okay, we don't write the base e, we use the natural log. This is just how I mentioned that the natural base, the number e, is always our preference in calculus. The natural log, exactly the same way, is always our preference in calculus. It is much easier to work with than anything else, okay? So, you can plug that in your calculator just the same. If I wanted to put in the natural log of 5 into my calculator, the natural log of 5, according to mine, is 1.609. Okay, that means that e to the 1.609 power is about 5. Okay, so natural log is just the same as any other log. So if I want to find the domain, that means that 3 minus x needs to be greater than 0. So we get negative x is greater than negative 3. Always keep your x's on the left when it comes to inequalities. And then we divide by negative 1, which flips this. So we want x is less than 3. There's a squirrel outside. So negative infinity to 3 is our domain. Now for B, this is a little bit trickier, but not necessarily harder. It's a little more interesting, I guess I should say. We need x minus 3 squared to be greater than 0. Well, no matter what you put in for x, you're going to square it. That's always going to be greater than 0. So really, the only thing that we cannot have is equal to 0. So x cannot equal 3 here. Any other number is fine because it's going to be a positive number after you square it. But 3 would give us 0, and that's bad. So our domain would be negative infinity to 3, union 3 to infinity. Okay? So that's a refresher on domains, common logs, natural logs. And in the next couple sections, we're going to start focusing on log properties, which are really important, and then solving exponential and log equations, which is really the goal of all of this stuff. So I will see you later.